Hello, very good morning. Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are going to discuss about the very interesting polynomials. Already I told you, according to your CSIR syllabus, each and every topic, from each and every topic, I am taking one old question I am discussing to you in this YouTube channel. If you really likes my teaching, you go to the Play Store in your Android mobile phone and download our app, that is the Quantum Online Academy app, and see the stores. Their courses are available. If you really likes my teaching, you have to purchase my course. Clear? So now today we will discuss about the polynomial. In that particular, I am taking about the Laguerre polynomial. Clear? About the Laguerre polynomial, one question I took, that question is TS set 2018, they are asking this question. TS set, Telangana State Lectureship Examination. So eligibility test, that is the 2018 they conducted the exam, that they are asking match the following: Legendre polynomial, Bessel polynomial, Hermite polynomial, and Laguerre polynomial. All polynomials they are giving, not polynomial, generating functions of the polynomials they are giving. So what are the generating functions of the polynomial? Once you have to see 1, 2, 3, 4 they are giving. In the this side they are giving a B, C, D they are giving. So if you have to adjust that, what is the Legendre polynomial, what is the Bessel polynomial, what is the Hermite polynomial, what is a Laguerre polynomial. First I will teach to you, I will give the polynomials, I will give generating functions, I will give. First you have to see what is the generating function of, which one it is, generating function. Generating function of whom? Generating function of generating functions of first Legendre polynomial I am giving. First polynomial is Legendre polynomial. Generating function of Legendre's special function or Legendre's polynomial. What is the generating function of a Legendre polynomial? Legendre polynomial is equal to summation n is equal to 0 to infinite z to the power of n into Pn of x is equal to summation n is equal to 0 to infinite z to the power of n into Pn of x is equal to 1 minus 2xz 1 minus 2xz plus z square 1 minus 2xz plus z square all to the power of minus 1 by 2. This is the generating function of a Legendre polynomial. This is very, very important. Generating function of a Legendre polynomial. The second one you have to see. What is the second polynomial? Bessel polynomial. Yesterday I took this one, Bessel's polynomial. Once you have to take the generating function of a Bessel polynomial. What is the generating function of a Bessel polynomial? Summation n is equal to minus infinite to plus infinite. N is equal to minus infinite to plus infinite. Z to the power of n into Jn of x is equal to, this is the Bessel polynomial symbol, Jn of x is equal to e to the power of x by 2 into e to the power of x by 2 into z minus 1 by z. This is the generating function of a, which polynomial it is? Bessel polynomial. Generating function of a Bessel polynomial. Now the third one, what is the generating function of a Hermite's polynomial? Hermite's polynomial. Which polynomial it is? Generating function of a Hermite's polynomial. Already in the first class itself I told summation n is equal to 0 to infinite hn of x into, so hn of x into z to the power of n is divided by n factorial is equal to z to the power of n is divided by n factorial is equal to e to the power of 2xz minus z square, e to the power of 2xz minus z square. This is the generating function of a Hermite polynomial. Now the fourth polynomial is, what is that polynomial? Laguerre polynomial. Laguerre polynomial. What is the generating function of a Laguerre polynomial? This is also very, very important. So generating function of a Laguerre polynomial is summation n is equal to 0 to infinite z to the power of n. What is the Laguerre polynomial symbol? Ln of x. Summation n is equal to 0 to infinite z to the power of n. Ln of x is equal to e to the power of minus xz is divided by e to the power of minus xz is divided by 1 minus z whole divided by 1 minus z is there. This is the generating function of whom? Generating function of a Laguerre polynomial. Now I am coming into the options. First, once again, you have to see generating functions of the Legendre polynomial is equal to summation n is equal to 0 to infinite z to the power of n Pn of x is equal to 1 minus 2xz plus z square whole to the power of minus 1 by 2. Generating function of a Bessel's polynomial is equal to summation n is equal to minus infinite to plus infinite z to the power of n Jn of x is equal to e to the power of x by 2 z minus 1 by z. Generating function of a Hermite polynomial is equal to summation n is equal to 0 to infinite hn of x z to the power of n by n factorial is equal to e to the power of 2xz minus z square. Generating function of a Legendre polynomial is equal to summation n is equal to 0 to infinite z to the power of n ln of x is equal to e to the power of minus xz by 1 minus z is all divided by 1 minus z is there. This is the generating functions of a special function. These four special functions are there according to your syllabus also. That's why I took this question. Now you have to adjust. What is the generating function of a Legendre polynomial? What is the generating function of a Legendre polynomial? Legendre polynomial generating function is equal to, so Legendre polynomial generating function is equal to 1 minus 2xt plus t square whole to the power of minus 1 by 2. Correct? So this is the, in terms of z, they are giving the options in terms of t. T is equal to, you have to take it as a z. So therefore you are getting the Legendre polynomial. Next you have to see what is the generating function of Bessel's polynomial. What is the generating function of a Bessel's polynomial? The generating function of a Bessel polynomial, once again you have to see what is the generating function of a Bessel polynomial. E to the power of x by 2 z minus 1 by z is there. Therefore what we have to write? Generating function of a Bessel polynomial. So e to the power of x by 2, e to the power of x by 2 instead of z, what we have to write? E to the power of x by 2. So e to the power of x by 2, we have to take it as z minus 1 by z. This is the t minus 1 by t. Which one we have to write? T minus 1 by t. So t minus 1 by t. There is a printing mistake is there. T minus 1 by t. That is x by 2 into t minus 1 by t. Instead of z, how to consider as a t, have to consider. Instead of z, how to consider as a t. T minus 1 by t. That is the Bessel polynomial. That option is C. Now I am going to the Hermite polynomial. What is the generating function of a Hermite polynomial? The generating function of the Hermite polynomial is, so which one we have to take? Option D I have to take. Why I am taking the option D? The generating function of a Hermite polynomial is equal to e to the power of, which one we have to write? So e to the power of 2xz 2xt minus z square is equal to t square. So this one what we have to write? Once you have to see, I am rearranging e to the power of x square minus t minus x whole square we have to write. X square is x square only minus, so you have to apply the a minus b whole square, t square plus x square minus 2tx, correct? Now you have to subtract that e to the power of x square minus t square minus x square plus 2tx. Minus x square plus x square get cancelled. Therefore, e to the power of 2tx minus t square only we are getting. So the same principle we are getting. So that's why this is the generating function of a, which polynomial? Hermite polynomial. Lastly, they are remaining, what is that? Generating function of a Laguerre polynomial. E to the power of xt is divided by 1 minus t, all divided by 1 minus t is there. This is the generating function of a Laguerre polynomial. What is your option? Your option is, once again you have to take, 1 is B and 2 is which one we have to take? C, and 3 is D, and 4th is A. So therefore B, C, D, A. Your answer is C is correct, your answer. Why I took this one? Here, why I took this question means here all polynomials are covered. All polynomials generating functions are covered. That's why I took. So once again you have to remember the generating functions of A. So Legendre polynomial, Bessel polynomial, Hermite polynomial, and Laguerre polynomial. These polynomials are very, very important. You may get in CSIR. How many marks you are getting? In CSIR you may get 3.5 marks. You remember these 4 polynomials, you will get the 3.5 marks you able to get. How many marks you able to get? 3.5 marks you able to get. If you really likes my teaching, we started the courses CSR and GATE purely online mode only. Wherever you there, wherever in your home, you take your mobile phone, that is Android mobile phone, take to go to the Play Store and download our Quantum Online Academy app. Quantum Online Academy app. If you have facing any problem, technical problem, you consult me. This is my personal number 9908437460. Maybe next year there is a job calendar is there. In that job calendar, JL physics and DL physics notification going to come, whether it may be Gurukulas or regular notification. So once a notification will come, they will conduct the exam within 50 or 60 days. They will conduct within 2 months. You unable to cover the entire the portion. That's why you able to take the coaching before. It is will be helps you in your competitive exams. If you really likes DL physics you want to take, you should take. JL physics you want to take, you should take. Otherwise, if you have to any lack in a particular special subject, total 9 papers we have: mathematical methods of physics, classical mechanics, quantum mechanics, electromagnetic theory, electronics, thermodynamics and statistical mechanics, condensed matter physics, atomic molecular physics, and nuclear and particle physics. Like this 9 specialized papers are there. In 9 papers, any one paper you unable to understand, those paper also you have to take, not entire the course. Like this courses will appear on our app. Please go to the Play Store and download our app and listen our classes and decide whether you want to take the course or not. So please share and subscribe our YouTube channel. Thank you. We will meet you tomorrow with another polynomial. That polynomial is the Legendre polynomial. Thank you so much.